In this video, I want to show you how to use the completing the square method. Now, typically we have a quadratic equation, ax squared plus bx plus c equals to 0. And the first thing you need to do is to isolate the terms with the variable to one side and then let the constant side be on the other one. So we're going to have something like ax squared plus bx equals negative c. And then the next step is to let the term with the x squared be alone. So you're going to divide through by a. So if you divide through by a, you're going to have x squared plus b over a x equals negative c over a. And once you have been able to write your quadratic equation in this format, then you are ready to complete the square, because this is exactly where the completing the square starts from. So before we proceed, I want to show you some things like the expansion of x plus 1 raised to power 2, the expansion of x minus 2 raised to power 2, and the expansion of x plus 3 raised to power 2. So I'm going to be using these three things to explain something right here, and I'm going to be showing you how it affects completing the square. What exactly does it mean to say we want to complete the square in any given expression? So the expansion of this is going to be x squared plus 2x plus 1. So if you know how to do your expansion, you should be able to get that. The expansion of this is going to be x squared minus 4x, then it's going to be plus 4. And the expansion of this is going to be x squared plus 6x plus 9. Now, here's what I want us to notice here. So let's say I rule out this portion, and this is the part that we only have. These guys will not give a perfect square, that is expansion of x plus 1, x minus 2, x plus 3 all squared. Now, we needed to add something to complete the square, and it seemed like these numbers are perfectly what we need to add to complete the square. But these numbers also have similarities with the number right in the middle, I mean the coefficients of x. So here we have these, they are related. These guys are related as well. And how are they related? So you would notice that these constant terms, this is the same thing as 1 squared. This can be written as negative 2 squared, and this can be written as 3 squared. Now, this negative 2, starting from this one is the half of the guy that is here. This negative 2 is the half of the guy that is here. And this 3 is the half of the guy that is here. That implies that if I should have an expression, let's say x squared plus 10x, if I'm looking for what to add here to complete the square, I just need to get the half of 10. The half of 10 is 5, and I'm going to square it. So if I add 5 squared to this place, then this should give me a perfect square, and I'm going to have something like x plus 5 raised to the power of 2. Let's take another one. If I have x squared minus 8x, what would I need to add to make this guy complete? The half of negative 8 is negative 4, so I'm going to add negative 4 squared, and this is going to imply this is x minus 4 raised to power 2. And this is exactly what the concept of completing the square method is all about. So you just have to look for the half of the coefficient of x, then you square it and you add it to your expression. And with that, you would have been able to do what we call completing the square. So that part exactly is where the concept of completing the square, that is where it comes from. And so you should be able to apply that randomly whenever you're solving a problem that needs you to apply it. So let's go back to what we're trying to do. We arrived at the point x squared. So let me quickly pull that down here. We arrive at the point x squared plus b over ax equals negative c over a. So I want to complete the square from this left hand side. So to complete the square, this is the coefficient of x, b over a. So what do I need to do? I need to find the half of that, half of b over a, and that is definitely b divided by 2a. So to complete this square now, I will need to say x squared plus b over ax plus b over 2a squared equals negative c over a. The only problem we have here is that I've introduced a new thing into the original equation, that is b over 2a squared. Since we have an equation, what you do to make sure that this has no net effect on the whole system is to add it as well on the other side. If let's say you're not dealing with an equation, whenever you bring in something like this and you are adding it inside, you also subtract it as well. What I mean is that if you're bringing in plus b over 2a squared, then you say minus b over 2a squared as well. So with this part, you're going to be able to complete the square, and this will follow the rest of the equation. So, but this place, we don't need to worry about that because we are dealing with equations, so we have to add it on both ends. So let's continue now. Now that we have this, going by what I illustrated earlier, so you would notice that this can now become, so all you need to do is to pick the x from here and pick the b over 2a from here. So this will become x plus b over 2a all raised to power 2, and this will be negative c over a plus b squared divided by 4a squared. Let's quickly get rid of what is here on this place. So the LCM is going to be 4a squared, and when a divides 4a squared, you're going to be left with 4a. So 4a times negative c, that's going to be negative 4ac. Then you have 4a squared divides 4a squared, that's going to be 1. 1 times b squared, that's going to be b squared. So right hand side is done. Let's still bring this down. So we have x plus b over 2a raised to power 2. Now, the goal of this is to actually solve for x. So then we can take the square root of both sides here. So take the square root of both sides. One thing about taking the square root is that because of the quadratic equation that we are solving for, we're looking for the solution of this. We're not looking for the principal root of this. So we can have the positive or the negative value. The reason is because what we are solving here is actually a quadratic equation. So we know that we have two values for our solution. So this place, then we are going to have x plus b over 2a. So that will be plus or minus. So if I split the square root and I decide to write the positive terms first, so I'm going to have b squared minus 4ac at the top divided by the square root of 4a squared. And that is going to be x equals, I can take the plus b over 2a to the other side. That will be negative b over 2a plus or minus square root of b squared minus 4ac, everything divided by, now square root of 4 is 2 and square root of a squared is a. So what we notice here is that they both have the same denominator, so that implies that x is going to be, we choose the common denominator, which is 2a, and that's going to be negative b plus or minus square root of b squared minus 4ac. And this is exactly how you apply the completing the square method, the step-by-step guide. And once you can see that it leads us to the quadratic formula, actually, negative b plus or minus square root of b squared minus 4ac divided by 2a. And take note of this guy inside, b squared minus 4ac. It is called your discriminant. Now let's quickly take an example. So for instance, if we are to solve this quadratic equation, let's say we have 2x raised to power 2 minus 3x plus 5 equals 0. So let's solve this guy using the completing the square method. So the first thing we're going to do is that we're going to say 2x squared minus 3x equals negative 5. So take the positive 5 to the other side. So then I divide through by 2. That's going to give me x squared negative 3 over 2x equals negative 5 over 2. Then I need to complete the square now. So to complete the square, I'm going to need the half of negative 3 over 2. So the half of negative 3 over 2 is going to be negative 3 over 4. So I'm going to bring that here. So that's going to be x squared minus 3 over 2x plus negative 3 over 4 squared equals minus 5 over 2 plus negative 3 over 4 squared. Never forget that whatever you're doing to the left hand side, you do it to the right hand side of the equation as well. So if we follow what I explained earlier, you realize that these two guys will form the square that we have completed. So that's going to be this entire expansion is going to be x minus 3 over 4 all squared. And so we can simplify this. This will be negative 5 over 2 plus negative 3 squared is 9 and 4 squared is 16. So let's quickly take the LCM of that. The LCM of this is 16. So 2 goes in 16, that's 8 times. And 8 times negative 5, that's negative 40. Plus, this will be 9. This will be 9. And so we still have x minus 3 over 4 raised to power 2 here. So 9 minus 40, that should be negative 31. So we have x minus 3 over 4 is negative 31 divided by 16. Negative 31 divided by 16. Now, so we take the square root of both sides. So the square root of both sides, so we're going to have this cancel out. So we're going to have x minus 3 over 4 equals, so you can split the square root here. So you have square root of negative 31 divided by square root of 16. So that implies x is going to be, when negative 3 over 4 goes to the other side, you're going to have 3 over 4 plus or minus square root of negative 31 divided by 4. Square root of 16 is 4. And this is going to imply x equals, since they have the same LCM, so it's going to have 4, 3 plus or minus. Now, square root of negative 31, we just know that 31 does not have a perfect square root, so just repeat square root of 31. And to take note of the negative sign inside, that is going to give us I. I is the square root of negative 1. So that implies that this is actually a complex solution, an imaginary solution. We don't have real solutions like just ordinary numbers. We have the solution of the form a plus b I. So the two solutions are going to be, so x1 is going to be 3 plus square root of 31i divided by 4. And x2 is going to be 3 minus square root of 31i divided by 4. And these are going to be the two solutions of that quadratic equation. And that's simply how you apply the completing the square method. If you want to see more videos like this, don't forget to subscribe, like, comment. I'll see you in the next one.